with respect to chapter 1, that is fundamentals of electrical circuits. I'm starting lecture 8. In this session, mainly how to see some important terminology in network theory and what exactly the concept of KCL and KVL, that is Kirchhoff's current law and Kirchhoff's voltage law. Students, you know what is the difference between the circuit and network? This is the definition of the circuit. An interconnection of electrical elements such that closed path available for the flow of current or charge is called circuit. That is, a circuit is a interconnection of electrical element and it must be a closed path. This is important. Circuit is a closed path for the flow of current or charge. Say, for example, let this is the voltage source, then one resistive element, let this is one inductor, let this is one more resistive element, let this is one capacitor, this is L, this is C, this is V. This total is the one circuit. There is a closed path is available for the flow of current. Here is what exactly the definition of the circuit. But what are the network steps? Interconnection of network element which may or may not have closed path for the flow of current. May or may not have closed path available is called network. See, for example, that this is the network, that this is one resistor, this is also one resistor, that this is the an inductor, and this is the capacitor. And here I am drawing one more L. And this is R1, this is R2, this is L, this is C, and this is R. Here there is no closed path for flow of current, and there is a closed path. That is interconnection of network elements which may or may not have closed path. If the closed path is present or closed path is not present, then it is treated as a network. But is circuit must have closed path. Network is may or may not have closed path. Then what is the observation here, friends? Every circuit is a network, but every network is not a circuit because circuit must have closed path. Okay, this is the statement that I am writing. Every network is a that is every network is a that is circuit must have closed path. That's why all circuits are every network is a circuit. But every circuit, shall I write like this instead of writing like this? Simply I can write like this. This type of statements are important for theory questions. All circuits are, can write like this. All circuits are networks. All circuits are networks. But all networks is not a circuit. All networks are not a circuits. Not a circuits. Except this, all circuits are networks, but all networks not a circuit. Because network may or may not have closure path, but circuit must have closure path. Say, for example, this is the network, and this may be treated as a circuit. Circuit is a subset of networks. Therefore, circuit is a subset of network. Subset of circuit is a subset of network. Here is a difference between circuit and a network. Next, you have to see what is the node, what is the degree of nodes. A point where two or more elements are connected is called node. Students, once again, I'm repeating this statement. Actually, this session I taken previously, but it is not recorded. That's why once again I'm taking this one. Who are attended already this session, can leave. But if you want once again, then you can listen this. The continuation of this session, continuation of that is this topic will be continued in the evening session. A point where two or more elements are connected is called node. What the degree of nodes is? Number of elements connected to a node is called as degree of node. How many number of elements are connected to the node is called degree of node. Let's consider this is one circuit. This is one circuit. R1. This is R2. Let this is L. And this is R3. Let this is the source. Then a point where two or more elements are connected. This is one element. This is one element. These two elements are connected. This is one node. This is one element. This is one element. This is one element. This is one node. This is one element. This is one element. This is also one node. And this total, if all these points are connected through one wire, then it is also treated as one node, that is single node. Then total how many nodes here, friends? It's a 4 nodes. The point to remember here, this is the node point. If all the points are connected through single wire, then it is taken as a single node. These points, this is one point, this is one point, but all these are connected to single wire. If all the points are connected, through single wire, through single wire, then it is treated as a, then it is taken as a single node. Then it is taken as a single node. This point you have to remember, single node. This is the single node. Then what is the degree of nodes? Number of elements connected to a node is called degree of node. For this node, how many elements are connected? 2 elements. That's why degree of node equal to 2. This is one element, this is one element. For this node, how many elements are connected? 3 elements. What is the degree of node? Degree of node equal to 3. Degree of node equal to 3. For this node, how many elements are connected? 2 elements. This is one element, this is one element. Degree of node equal to 2. For this node, how many elements are connected? 1, 2, 3. Then degree of node equal to 3. The number of elements connected to node is called degree of node. But here, how many elements are connected? 2 elements. Then it is called simple node. Here, how many elements are connected? 3 elements. Then this is called principal node. Principal node. That is, at any node, if 2 elements are connected, then it is called simple node. At any node, if 2 elements are connected, then it is called simple node. At any node, if 3 or more than 3 is connected, 3 elements or more than 3 elements are connected, or that is, at any node, if more than 2 elements are connected, if more than 2 elements are connected, then it is a principal node. Principal node. This is about node and degree of node. Then what is the branch? An element that connects 2 nodes together is called branch. Say for example, this is one resistance. This is also one resistance. Let this is also one resistance. Let this is one inductance. Let this is one capacitance. Let this is the source. Then how many number of branches are there? This is R1, R2, R3, C, L. This is V. An element that connects 2 nodes together is called branch. The number of branches equal to, in this case, number of branches denoted by B. How many number of branches are there? Here, how many branches are there? How to take? V is one branch, R1 is one branch, R2 is also one branch, R3 is also one branch, L is one branch, C is also one branch. An element that connects two nodes. Here nodes are which nodes? These are the nodes now. This is A, this is B, this is C, this is the D. How many nodes? Totally 4 nodes. 4 nodes. How many branches are there, students? The number of branches equal to 1, 2, 3, 4, 5, 6. 6 branches. Nodes equal to 4. Nodes equal to 4 nodes. Now I have to calculate degree of node. What is the degree of node? For node A, the degree of node equal to 3. For this node, this total is node only. For this node, how many elements are connected? 1, 2, 3 elements. What is the degree of node for B? How many elements? 1, 2, 3 elements are connected. Degree of node equal to 3. For this node, how many elements are connected? 1, 2, 3. Degree of node equal to 3. For this node, how many elements are connected? 1, 2, 3. Degree of node equal to 3. If you add all the degree of node, this we are getting 12. What is one observation here, friends? The number of branches equal to 6. The sum of the degree of nodes equal to 12. That means sum of the degree of nodes equal to, shall I write like this? Sum of the degree of node equal to sum of the degree of node equal to 12. This 12 I am writing 2 into 6. What is 6 here? Number of branches. 2 times of branches. Sum of the degree of node equal to 2 times of the branches. Therefore, I will write like this. Any number of nodes are present. Summation I equal to 1 to n di. You have to add all the degree of nodes. This is 2 times of the branches. You have to add all the sum of the branches. You have to add all the sum of the degree of nodes, that is equal to 2 times of the branches. Yeah, this observation is important that you have to pass. This is about what is the branch. Next, what is the loop? What is the mesh? It is a closed path in a network. A path that starts and ends on same point. That is, loop is the closed path. But no doubt at all, mesh also closed path. But in loop, internally, there exist a subloops. But mesh is independent loop only. Independent. See, for example, let this is one circuit. This is one circuit. This is R1. Let this is one more resistor R2. Let this is one inductance. Let this one more resistor R3. Then in this case, how many loops are present? Let this is R1. This is R2. This is R3. And this is L. The number of loops are, this is one loop. This is another loop. And this also loops. This also treated as a loop. This also treated as a loop. Therefore, number of loops equal to 3 here. L1, L2, L3. The number of loops equal to 3. But what the mesh? A loop in which we can't form any smaller loops. A loop in which we can't form any smaller loop. Inside is called mesh. Meshes are that is specifically called independent loops. That is, for example, how to take like this. Same example I am taking. This is R1. Write clearly. Yes, this is R1. This is R1. And this is R2. Let this is L. And this is R2. You take like this. This is R1. This is R2. This is L. This is one mesh. And this is also mesh. But don't take this is the mesh. L1 loop is the mesh. L2 loop is the mesh. But L3 loop is not a mesh. That is a loop, but it is not a mesh. If you take that one, L3 is the mesh. But if you take L3 is the mesh, smaller loops are formed inside. Smaller loops are formed inside. That's why it is not a mesh. A loop in which we can't form any smaller loops. If L3 loop is the mesh, internally L1, L2 smaller loops are there. That's why it is not a mesh. Clear, friends? A loop in which We can't form any smaller loops. See, this is one mesh, but internally there is no loops. This is one mesh, internally there is no loops. But if you take this L3 is the mesh, internally L1, L2 is there. That's the reason why L3 is not a mesh. Therefore, number of meshes equal to 2. In this case, the number of meshes equal to this, and this is the meshes. The number of meshes equal to 2. That is, if it is a loop, if you take it is the loop, and this is the mesh. That means what is the meaning of this? Mesh is the subset of loop. That is, mesh is the part of the loop. Mesh is the subset of loop. Subset of loop. All meshes are loops, but all loops are not meshes. Students, all meshes are loops. All meshes are loops, but all loops not mesh. All loops are not mesh. L3 is the loop, but not a mesh. L1, L2 is the this is the mesh. This is the mesh. This also loops. That's the reason why all meshes are the loops, but all loops is not a mesh. All loops is not a mesh. Okay, this is the difference between loop and mesh that you have to concentrate. Next. Here I have to give one observation that is important that you have to concentrate. See, for example, this is the one circuit. This is the one circuit. This is R1. This is R2. Let this is the source. I'll take this one more element. This is R3. Let this is the inductor. This is the resistance. How to write how many number of nodes are there, number of branches are there. Let this is node, this is node, this is node, this also. The number of nodes equal to, in this example, number of nodes equal to, this is n, equal to 4. Number of branches equal to number of branches. The number of branch equal to, how many branch? 1, 2, 3, 4, 5. That is the 5 branch. Number of meshes are independent loops. How many number of meshes? This is one mesh, this is one mesh. 2 meshes. Shall I write like this, friends? How we can get this 2? 5 minus 4 plus 1 equal to 2. Na? 5 minus 4 plus 1 equal to 2. What is the 5 here? Number of branches. What is 4 here? Number of nodes. Plus 1 equal to number of meshes. Get this formula. Number of meshes are number of independent loops. Number of meshes are number of independent loops, not the loops. Number of independent loops. Number of independent loops. M equal to B minus N plus 1. Where B equal to number of branches, N equal to number of nodes plus 1. The number of meshes are number of independent loops equal to B minus N plus 1. That you have to consider. Next, one more important terminology. What is the planar network? What is the non-planar network? Any network that can be drawn in two-dimensional plane is called planar network. You have to draw the network in two-dimensional plane without any overlap. Then it is stated as a planar network. It can be represented in a plane without overlap any element. Both mesh and nodal analysis is valid for the planar network. For planar network, you have to apply the nodal analysis and mesh analysis. See, for example, this circuit and this circuit is same. That is, this network and this network is same. This network I am drawing like this without any overlap. There is no any overlapping of the element. You have same network I am drawing here. Total how many resistors are there? 1, 2, 3, 4, 5, 6 resistors. Here also 6 resistors. 1, 2, 3, 4, 5, 6 resistors. The same network I drawn like this, but there is no any overlap. That's why it is a planar network. See the one more example. The same network I am drawing like this. Here number of elements, here number of elements are same. But same network I have drawn here in the two-dimensional plane without any overlap, without any overlapping of elements. That's why it is also planar network. Then what is the non-planar network? Any network which cannot be drawn two-dimensional plane is called non-planar network. That is having overlap in representation. If it is having overlap in representation, then it is a non-planar. But for non-planar, only nodal analysis is valid for us. You have to apply only what is the nodal analysis, mesh analysis. Let me see this network and this network is same. But I am drawing this network like this, then there is overlapping of the element. There is overlapping of the element. That's why it is treated as a when there is overlapping of this element, this is also treated as a non-planar network. This is what the difference between the planar network and non-planar. But for planar network, both nodal and mesh analysis is applicable. But for non-planar network, only nodal analysis is valid. This is the terminology with respect to circuit theory. These are some important terminology. Now, with this knowledge, now you have to concentrate what is the Kirchhoff's law. What are the Kirchhoff's laws for electrical circuits? So there are some simple relationships between the currents and the voltages of different branches of any electrical circuit. These relationships are determined by some basic laws that are known as Kirchhoff's laws, or more specifically, Kirchhoff's current and voltage laws. To represent the relation between voltage and current in a different branches of the circuit, we have to use the basic laws. Those basic laws are the Kirchhoff's laws, that is Kirchhoff voltage law and Kirchhoff current law. These laws are first derived by Robert Kirchhoff, and hence these laws are also referred as Kirchhoff's laws. Then what are the Kirchhoff's laws, friends? Kirchhoff's first law, and another one is Kirchhoff's second law. The Kirchhoff's first law is KCL, that is Kirchhoff's current law. Kirchhoff's second law is KVL, that is Kirchhoff's voltage law. Kirchhoff's voltage law, that is KVL. Now how to say Kirchhoff's first law, that is Kirchhoff's current law, that is KCL. KCL is always defined at a node. Important observations. You have to define the KCL at a node. According to Kirchhoff's current law, the total current entering a junction or node equal to the current leaving the node as no charge is lost. That is, current entering the node equal to current leaving the node as no charge is lost. See, for example, let's consider this is one node. I1, I2, I3 are entering the nodes. I4, I5 is leaving the node. In general, you have to take the current entering is negative, current leaving is the positive. Opposite also you have to take. But here I am taking current entering is negative. Minus I1, minus I2, minus I3. Which are leaving, students? I4 and I5. Plus I4 plus I5 equal to 0. Then from this, I1 plus I2 plus I3 equal to I4 plus I4. That is, sum of the entering currents at node equal to sum of the leaving currents at a node. That is, entering currents equal to leaving currents. That is sum of the entering currents. These are sum of the entering currents. Sum of the entering currents at a node equal to sum of the leaving currents at a node. Leaving currents at a node. Sum of the entering currents at a node equal to sum of the leaving currents at a node. We can also write the currents like this, friends. I1 equal to dq1 by dt. I2 equal to dq2 by dt. I3 equal to dq3 by dt. This is equal to I4 equal to dq4 by dt. I5 equal to dq5 by dt. Shall I write like this? Q1 plus Q2 plus Q3 equal to Q4 plus Q5. That is, sum of the entering charge equal to sum of the leaving charge at a node. That is the sum of the charge, sum of the entering charge at a node equal to sum of the leaving charge at a node. Leaving charge at a node. Sum of the entering charge at a node equal to sum of the leaving charge at a node. This is what exactly KCL is. But here you have to concentrate these observations. KCL applies to any lumped electric network. It does not matter whether element is linear, non-linear, active, passive, time invariant, and time variant. That is, whatever may be the element, it is applied for the lumped electric network. It is applied for the lumped electric network. That is, KCL is based on the principle of law of conservation of charge. It is based on the principle of law of conservation of charge. This one. Therefore, sum of the entering charge at a node equals sum of the leaving charge at a node. Therefore, it is based on the law of conservation of charge. Law of conservation of charge. Next. KCL is independent of nature of element connected to the node. Whatever the element it is connected, or to connect any element at a node, resistor, inductor, capacitor, current source, whatever may the node element is connected, that is independent of the element connected at a node. Say for example, if there is an inductor is connected at a node, let there is a capacitor is connected at a node, let there is a one current source is connected at a node, let there is a resistor is connected at a node, let this current is IL, let this current is IC, let this is I, let this is IR. Sum of the entering currents equal to sum of the leaving currents. Then IR equal, this is leaving. IL is entering, IC is entering, I is also entering. I plus IL plus IC. That's the name. Whatever the elements is connected, it is independent of type of element, nature of element connected to one. In nodal analysis, we may neglect simple nodes, but one of the principal node is considered as a reference node. So the minimum number of KCL equations required to solve the circuit or network is NP minus 1. Important. This formula is useful in nodal analysis. Actually, in the nodal analysis, we can neglect the simple nodes. We have to consider the principal node only. In that principal nodes, one node is taken as a reference. Then how many number of KCL equations are required in nodal analysis? That is NP minus 1, where NP equal to number of principal nodes. NP equal to number of principal nodes. Yes, friends, this is about the session. Actually, I taken this session because in the previous session that is not recorded. So we are seeing for recorded classes once again. For that reason only I taken this one. The continuation of that, the other students also will attend in the evening session. That's the reason why in the evening session I will continue with what the Kirchhoff's voltage law, how to consider the sign convention. This is very important. Then what is the Kirchhoff's voltage law? Then I will solve different models of questions also with respect to KVL. And finally, I will give some conclusion points. Some models of questions also. This is about the session. Thank you very much. Friends, any doubt? Okay, I'm ending the session. Thank you.